So I apologized. Something interfered before I can do 9 and 10. So we're going to do them in just a little short video here. So this one, doing the special work for. Just a reminder, that's a 1 there. So A would be equal to 1. B would be -3. And our C would be the -6. So if we want to have our solutions, it's already set equal to 0, so I can do this. Always make sure it's set equal to 0 first. Okay. So we said B was -3, so we're going to put in -3. So it's going to turn to a positive. Plus or minus the square root of that -3 squared minus 4 times A, which is 1, and then C, which is -6. And then this is going to be over 2, 1, because A is 1. So we have 3 plus or minus the square root of 9 minus plus 24 over 2. Get my calculator out because this is going to be so messy. Okay. So we're going to have 3 plus or minus the square root, if we add that, is 33 over 2. So we can't simplify square root of 33 anymore. There's no squares in there. 33 is just 3 and 11 times 11. So we're stuck with it. So like I said, we have two solutions as always. We have 3 minus square root of 33 over 2. And then we have x is equal 3 plus or minus the square root of 33 over 2. If we want to get our approximate answers, you'd have to have 3 minus the square root of 33. Then once you have that, divide it by 2. And we get -1.37. We'll just go out to the thousandths place again. So -1.372. If we have addition, then it's going to be the other one is approximately 4.372. And those would be my solutions. All right, and 10 is our very last one. So once again, we see that A should be 1, B is going to be 2, and C is going to be 3. So we got X. It's going to be equal to minus B plus or minus the square root of B squared minus 4AC over 2A. That is going to be a -2 plus or minus the square root of 2 squared minus 4 times 1 times 3. So there is going to be a problem here. And it has to do with the discriminant or what's under that square root. I can just checking something on my screen here. So let's see what that problem is going to be. So this is going to be 4. This is going to be 12. So right here is the issue is trying to do a square root of a negative. So we can't do the square root of a negative number, at least in the real numbers. So what we would say is we have no real number solution so in the past, you might have been told every time you have a square root of a negative, you have no solutions. That's partially correct. It's just no real number solution. Because what we're going to do here shortly is we're going to start looking at complex numbers. And then when we do complex numbers, we're going to come back to these and we're going to see that we can factor them if we're in the complex numbers. But this is another one if we graphed it. Once again, we see that it does not cross the x-axis. So this has no, like we said before, x-intercepts. So we call those x-intercepts roots in the real numbers. So we have no real roots. So because I have, once again, no x-intercepts, that means that if I set this equal to 0, this can't possibly happen because there's no time when y equals 0, there's a solution. So we have no real number solutions. So as stated, x squared minus 2x plus 3 equals 0. We would say there are no zeros or no solutions in the real numbers. Not all polynomials have real number zeros, but they will always have complex number zeros, which real numbers are part of the complex numbers. We'll get to there, which is something we're going to see here fairly soon. So I just want to bring up that discriminant. So when you apply the quadratic formula to any quadratic equation, you find that the value b squared minus 4ac can be positive, negative, or 0. So we didn't have a case of 0, but when it's 0, what happens is we just end up with one solution. This expression here is called your discriminant. So we know, if you want to see if you can even bother using quadratic formula for real number solutions, is you just look at that discriminant. If it's 0, that means that we should only have one solution, which means you're going to have something's going to come down. It's just going to touch the x-axis and turn away. If this in here is greater than 0, that means we have two solutions. So that means we have something that comes down, crosses, crosses again. And then once again, if it's less than 0, that means I can't do a square root because it's a negative number. So this is something that doesn't even bump the x-axis. So like I said, this is what your discriminant is, and this is what we use discriminants for you at this point, is really just to determine, do I have one solution, two solutions, or am I not going to have any solution in the real numbers? In that case, I'm going to have two different imaginary number solutions.